Could the days of deforestation be numbered? What role does technology play in this hopeful possibility? Deforestation, a pressing issue of our time, has been relentlessly stripping our planet of its green cover. The consequences are dire: loss of biodiversity, disruption of ecosystems, and the intensifying climate crisis. The need for a sustainable solution is clear and urgent. Enter 3D-printed lab-grown wood, a groundbreaking innovation that could revolutionize how we source timber. Back in May 2022, researchers at the Massachusetts Institute of Technology, led by Ashley Beckwith, astounded the world by creating the first piece of 3D-printed wood derived from the cells of a flowering plant, the Zinnia elegans. This marked the first ever use of tissue engineering for plant matter production. In a bid to further this technology, Beckwith founded 3D Bioscience. The aim? To expand these novel techniques to tree cells like pine, potentially putting an end to the destructive practices of deforestation. Imagine a world where we no longer need to cut down trees for timber. That's the world we are heading towards thanks to technology. So, what's this innovation all about? It's quite simple, yet groundbreaking. We're stepping into the realm of something incredibly unique. 3D-printed lab-grown wood. Yes, you heard it right. Wood grown in a lab, then 3D printed. So, how does this work? Let's start with the building blocks, the cells of a flowering plant known as Zinnia elegans. This plant isn't just your average garden variety, but rather the source of a revolution in how we produce wood. The process involves manipulating these cells in a laboratory setting, coaxing them to multiply and form tissues. This isn't just any tissue, though. It's wood tissue, complete with the grain and fibres that give natural wood its strength and character. Once this tissue is formed, it's then used as the ink in a 3D printer. And voila! You have a piece of wood grown and printed in a lab, customizable to various shapes and sizes without any wastage. Now, you may be wondering, who are the minds behind this game-changing innovation? It's the brainchild of researchers at the Massachusetts Institute of Technology, or MIT, as it's more commonly known. The lead author of this groundbreaking research, Ashley Beckwith, went on to establish 3D Bioscience, a company dedicated to advancing these wood-growing techniques. And what's the ultimate goal? To expand this method to include tree cells like pine, potentially making deforestation a thing of the past. Imagine that, a world where we no longer need to cut down trees for timber. In essence, we're talking about growing and printing wood in a lab without the need for cutting down a single tree. Mind-blowing, isn't it? But what does this mean for our future? How can this innovation change the world? The potential of lab-grown wood is almost as vast as the forests it could one day replace. Picture this, a world where the need for deforestation is eradicated. A world where our beloved old-growth forests teeming with biodiversity can stand tall and untouched as we grow our timber in labs instead of tearing it from the earth. This technology is not just about growing Zinnia elegans cells. The method developed by these pioneering researchers at MIT could be expanded to other tree cells, like those of the mighty pine. Imagine, if you will, the ability to grow any type of wood tailored to specific needs without cutting down a single tree. The implications for industries that rely heavily on timber are immense. Construction, furniture manufacturing, even paper production could all be revolutionized. We would no longer be constrained by the slow growth of trees or the limitations of certain wood types. Instead, we could engineer the perfect piece of timber for every purpose. But the benefits of lab-grown wood extend beyond the practical. This is a method that aligns with the principles of sustainability and respect for nature. We're not just talking about saving trees here. This approach could significantly reduce the carbon footprint associated with logging, transport, and processing of traditional timber. In addition, the customization potential of lab-grown wood could usher in a new era of design and architecture. Imagine buildings constructed with intricately shaped wooden parts, grown to specification, without the waste associated with traditional wood processing. The future of deforestation may indeed be numbered, and technology is leading the charge. We are on the brink of a new era, where we can enjoy the benefits of wood without the environmental cost. Now, isn't that a future worth striving for?